So the topic of our discussion is the future of mobile broadband or wireless broadband. And to discuss that, we have an amazing panel starting with Fred Kitson from Motorola, Corporate Vice President, followed by Chris Pearson, President of 3G Americas, David Achim, CEO of SkyFiber, Hugh Bradlow from Telstra, CTO, and Rama Shukla from Intel, VP Mobility Group. To start the discussion, I would like each of the panelists to comment on, and take about 2 minutes to comment on what has changed or what have been the key events in the last 12 to 14 months with respect to mobile broadband. And we'll start with you, Fred.
Well, first, I want to do a primer on why we're here, but certainly, broadband and wireless has something to do with, why people are mobile and their insatiable appetite for video. So certainly we see over the last 18 months, a rise in HD consumption, people looking at things like 3D TV, for example. So in terms of our investment in wireless broadband, what we're looking at is we're sort of trying to amortize our investment over both WiMAX and LTE. On the LTE front, actually, it turned out yesterday in Munich, we introduced something that's a sort of self-organizing network for LTE, actually at Munich at the LTE World National Summit. And what we're trying to do there is really take, actually, as Mark Hurd said, really software and use that as a sort of a compelling weapon. So we're trying to make, when you deploy this, you can deploy quickly, easily. It finds its neighboring satellites. It optimizes in terms of the radio. It also will automatically reconfigure when you have outages. So we're really looking at the software front there. In WiMAX, you see more traction. We have, I think, about 24 deployments around the world. They seem to be in a lot of places where countries have decided to go directly to 4G. We certainly have interactions with people like Clearwire in the US, and we have a pretty much exclusive deployment in Portland that we're looking at. And this year we're kind of rolling out to Atlanta and Las Vegas. And we plan to do on the order a little bit greater than $500 million, I think, in terms of revenue in WiMAX. And finally, on the device side, we have sort of fixed mobile convergence devices coming out. You'll see some that'll be, use up a little more power than you'd like, a little bit bulkier than you'd like, certainly now, but certainly the end of next year, and certainly by 2011, they'll be more of a commodity thing. So a lot of the devices that really today are WiMAX plus cellular, you'll see going to Wi-Fi and LTE.
Chris?
So, getting back to what's changed in the last 12 to 24 months, really, I think it's mobile broadband demand. I think, we probably in the industry have been talking about mobile broadband demand for quite a few years. Even going back to when we started launching 3G. But I think in the last 12 to 24 months, we've gone from a society that looked at it as kind of a niche play to really another way to be productive.
So what drove that demand? Is it just awareness or applications or?
I think it's the timing of the networks and the coverage, whether it's in the United States or throughout the world. So the networks got better as far as coverage and speed and throughput. But also I think if you look at the phenomenon of the smartphone, much better smartphones coming to market, making it much easier for either you to use it, your grandma to use it, your son or daughter to use it, and really, looking at what happened with some of the early smartphones, which was just, hey, it's great to be connected to email, and you saw that everywhere you went in the world with the business people, but it's transformed way beyond that now. It's not just an application of email for your smartphone; it's an application of being connected to the internet. So, the forecast I've seen, going out is, in the U.S. by 2013, you have 250 million mobile broadband users. That same year, it's expected to be about 1 billion worldwide mobile broadband users. So, what's changed in the last 12 to 24 months is the demand.
So from a definition perspective, you define broadband as 3G plus or 4G?
3G plus. Right now, if you look at the technologies that we heard about this morning from Telstra, and you'll probably hear about them again, with the later versions of HSPA or what's called HSPA plus, you're getting a lot of the next generation performance levels from the radio side with some of the techniques that they're using. So I think it's this continual timeline of improvement in the networks, and you're going to see it continue.
David, what has changed from a backhaul perspective?
Well, it's not just the back office perspective, but it's also, it's compounded by the fact that we see Facebook and these social interacting network applications that are driving demand in a huge way. I've got 4 kids in college, and I get constant, Facebook, Twitter, all the time, and that kind of activity is generally contributing to the overall 140% compound growth rate of mobility, and of course, it's having an effect on the backhaul. And when you start looking at the ability to surf up and support that kind of internet traffic and activity, it's putting stress on the existing networks, and I think that's part of where certainly a lot of the change is coming, and it's pushing the pressure points together to create both demand, and at the same time, the market's crying out for solutions to help provide capacity to deliver that.
Hugh, you sit in the middle of it. You see a lot of traffic and consumer behavior and consumer demand. From your perspective, what has changed?
So I think the biggest thing that's changed, Chetan, is that mobile broadband went crazy in 2008. Nokia quote a figure, they supply 11 operators, and they quote a figure of 1,000% average traffic growth during the calendar year of 2008. So that's just massive growth. I think the other thing that's changed, and because we led the way on wireless broadband, is the mobile internet. And by the mobile internet, I mean using the internet from your handset. Of course, Apple have kicked that along with the iPhone, but it's not just iPhones. Everyone is starting to see the benefit of using the internet from a handset, and that's a significant change. I would like to just comment on the things that haven't changed, though, and that's the overall ecosystem. People get focused on the radio interface, but actually all the back office stuff that you've got to do, the authentication, the voice systems, messaging systems, international roaming, those things don't change. And that's been one of the advantages of following the GSM track. We've been doing those same things now with the same technology base for the last 15 years. And we'll probably still be doing those same things in the next 15 years. And that's where all the money and time goes. So that's probably why you see the forecast that 3/4 of the world's mobile broadband users in 5 years' time will be on GSM track technologies. Whether it's HSPA or LTE, it doesn't really matter. The one thing I do want to comment on, WiMAX is not 4G. 4G is 100 megahertz bandwidth channels. No one can do that today. The technology doesn't allow you. So let's get the terminology clear.
Okay. Well, Rama, let's, we talked about technology, but is it about technology in sort of the next generation or fourth generation, whatever we call?
Well, technology is a means to an end, and coming from a technology company, maybe slightly different perspective that 4G, you just heard 4G is really 100 megahertz, but that's a technical definition. If I define 4G from a perspective of where we are today and what has changed, there are a few points I'd like to make. The first one is that, and you already heard that from almost everybody, that 4G is about mobile internet, mobile personalized internet. It's not about voice and data, which is a legacy mindset. We just take something and just make it a little bit better. That's 4G. No. 4G is about personalized mobile internet. So when you step back and say, what does that mean? It actually brings into question what business models and what usage models are we spawning from this, and what type of innovation this will drive. And once you recognize that, then it's like asking a question, if I have a house and I want to build just one more room for capacity, that's one way of looking at what you want to do, versus I want to live a different lifestyle. I want to have a different usage model. I want to build a brand new home. So I think 4G is about a whole new business model, entirely different approach in terms of the ecosystem, and more of an internet, which is basically a different infrastructure and different ecosystem-based approach to how people live their daily lives, both in business and personal.
So if it is about the business model, can you apply those business models to 3G?
You can, but the usage models, if you take a look at what's coming, and it's obviously that we don't know what we're doing in terms of once you enable mobile internet infrastructure, once you enable that way of delivering internet to people, it will spawn usage models which don't even exist today. That's one of the assertions I have. But known business models and known services today you can get, which are being designed for 4G today, they will work on 3G, but not as well. They will not give you the experience. They may not even have the economics. They may not make sense. A good example is, the operators today don't want to offer all-you-can-eat bandwidth. It's a very simple reason. It's unaffordable to them. And yet, when you are at home, imagine the amount of data bandwidth you require at home, and wouldn't you like to have the same thing when you are outside home and mobile? So I don't think we can achieve the experience and the futuristic model we have for what mobile broadband does with the classical approach of just let's add a little bit more capacity and a little bit more bandwidth.
So Hugh, clearly flat rate is becoming sort of the mode of operation for a number of operators. So is that model sustainable? Of course, we go to 4G, we get, the next generation technology, we get the benefits of the RF or all IP network and so on and so forth. But the driving prices down through the flat rate, is that sustainable, or do we need to introduce new tariffs or just a new way of thinking?
Well, look, let me deal with the point about the bandwidth economics here, because so-called 4G does not change that in the slightest. The bandwidth economics for mobile networks are defined by two things, by spectrum and by base stations. 3/4 of the actual build cost goes into the base stations. That's land, that's rent, that's putting up towers. It's all this sort of stuff that's not amenable to technology improvements. So those don't change. So the only way you change the economics are to put out more bits per base station. And the only way you can do that is by having wider spectral bands, because in fact, WiMAX, LTE, they don't actually change the bits per hertz much at all. By a 20-30% maximum is the difference in bits per hertz. So you've got to widen your channels. And that's a spectral issue, and you get charged for spectrum. So the economics of how much it costs you to deliver a bit are not going to change until you've got these wider bands, 20 megahertz, 100 megahertz. That's what changes the economics.
Well, it's not the only thing that changes that. There's a complementary technology like our company provides, which is a wireless light, which allows you to take advantage of a non-spectrum-based charging where you can deliver high-capacity bandwidth without necessarily doing that. Previous generations of the technology have suffered from fog and rain, and our company and others like us are punching through and extending the distance and the capacity to help deliver solutions into solving those problems. Because unless you can get, I think there's 287,000 cell towers in North America, and most of them have copper, and some of them have 1 or 2 T1s, and the projected, is that most of them are going to need somewhere between 6 and 8 T1s to extend that. So if you can't drive a massive amount of new bandwidth to those towers, we're not going to be able to meet the growing
So what's
demand.
the status? Is the industry working towards making sure that there's a good end-to-end bandwidth capacity available?
Yeah, it's not just end-to-end capacity, but it's all about building solutions. And networking today, our company is leading the charge in terms of providing mesh networking to be able to take advantage of putting these light networks together and then building redundant systems around that in order to provide the kind of service and reliability that the industry expects. But you got to look at the configuration of the requirements, of whether it's an urban area or a rural area you're trying to reach to, but it still is all about trying to configure the appropriate solution with the right configuration to solve the problem. You got to be in the solutions business in order to kind of attack these kinds of issues.
Chris,
Okay.
yeah, I had a question around spectrum. You raised a very important issue around spectrum. So what's the status with respect to spectrum for deploying next generation technology?
Well, in the U.S., we were actually, at the forefront of auctioning off what's called 700 spectrum for, basically it's going to be used for LTE, and then Clearwire has quite a good portfolio at the 2526 for WiMAX. But in many parts of the world, the world needs more spectrum, and they need coordinated spectrum or harmonized spectrum. They need basically market-type spectrum processes and rules so that anybody can bid on the spectrum. And we see this as 3G America is working on with governments throughout the Western Hemisphere that, like in Latin America, the strongest operators that are out there providing mobile broadband need more spectrum. But yet many of those governments are legislating as if it was a voice-centric world and capping them from getting the new spectrum that might come to market. So there is a lot of industry progress, a lot of lobbying, a lot of working through the appropriate channels to change this. But if you start talking about solutions, part of the solution is to bring more spectrum to market, because LTE and WiMAX, for those to get the real efficiencies, you got to have again wider channels, more spectrum. You also need to solve the economics of the backhaul, and which is a whole new topic that you kind of addressed. But as you said, the whole network has to be looked at when you start looking at next generation networks. It's not just going to be the radio. It's not just going to be the backhaul. The whole network has to be looked at as a total solution, because there is a great demand for mobile broadband, and that's the only way you're going to provide for it.
Yeah, I think probably that point we're seeing in actual deployments, and of course it depends whether it's someplace like Pakistan or whether you're talking about New York. But we're seeing actually the aggregate as being about 1/10 the cost ultimately per bit, which ultimately leads to application support video. So from an application point of view, I think what we're seeing when we call fourth generation is really the ability to have an iPhone experience as if you're with WiMAX. So it actually ends up being only 3 to 5 megabits per second, but that's what we're calling the fourth generation experience, which you can achieve with these technologies.
So from a consumer point of view, is it all about decreasing latency, or is it there more to it than just increasing the bandwidth?
Yeah, actually, I mean, latency ultimately is going to be key when you're doing interactivity and you're doing games, and some of the applications like social TV, social networking require it. But right now, the fundamental thing is to get the experience you have in the internet, which, as we all know, to a first-order approximation, the internet is video. About over half the traffic is actually video, and you want to get that in a mobile experience. So it's really consumption of video, and that is achievable. Matter of fact, the new platforms we have actually have a high-definition experience if you look at the size of the screen, relatively speaking.
Okay. Rama, you have something?
Yeah, we're talking about end-to-end solution for 4G, and we talk about spectrum. I completely agree that without having spectrum, you don't get the fundamental building blocks. Fortunately, in many of the countries, particularly in the emerging markets, I think the governments have realized that digital divide, the way to close that is to allocate spectrum for broadband. And in particular, mobile broadband is where I think the innovations will happen. So I see that as an opportunity, perhaps in some ways, where emerging markets may get ahead of established markets in deploying mobile broadband faster and quicker. And that's evident if you take a look at the number of trials happening.
Is that going to be true for both fixed wireless and mobile wireless?
Fixed wireless may be the way to start, but they're architecting it so they can take it mobile eventually. And the second point is, beside the spectrum and the backhaul and the obviously the base station, the radio infrastructure, you need two more things. You need devices. And I think one of the major breakthroughs in the last 2 years has been the emergence of new ultra-low power computing devices, which take the PC infrastructure, if you will, PC ecosystem, software, hardware, developer community, all the plugins in the internet, all the different things, the evolutionary, very dynamic nature of internet. You can port that right into mobile space by having the PC ecosystem support it. So that has been a fundamental change with the emergence of, for example, the Atom microprocessor, which was announced. Its growth has been unprecedented, and it is being looked at primarily by the community for nomadic and mobile computing experience as opposed to at home. Okay, so that tells me that iPhone is actually maybe just the first device which consumes the mobile broadband and shows you the possibility. But the ultimate devices for broadband on the go or mobile experience may not be anything which looks like a smartphone in terms of the amount of data it can consume and the type of services you may look for. So it's I think, fallacy to think that smartphone is the only thing which will drive mobile internet or mobile internet experience, because that really limits you in terms of screen size and what you can do with it.
Hugh, you have been looking at many more types of devices, not just netbooks and smartphones, but also wearable computers and sensors. And how do you see the new ecosystem evolve? Are there going to be many more device players in the market and with different types of functions?
I think the devices themselves are going to change dramatically. I agree with Rama. It's not just about iPhones. It's the whole netbook, notebook, laptop market, and that dominates traffic today. But interestingly enough, the forecast, Cisco did a study recently where they showed about a third of data is generated by handsets today. And in 5 years' time, that will have moved up to a half, despite the massive increase in these other devices. But I think the really exciting thing are going to be wearable displays and sensors attached to phones. So we heard in last night's dinner presentation, people in India are able to take a photograph of a filter. Well, it will be, one day you'll have things like biosensors built into the phone, pollution filters built into the phone that are automatically reporting. And I think that whole ecosystem, which I'm calling mobile internet, but it's about handset devices, is going to drive a lot. And you've got to remember that the actual data you require is proportional to the square of the diagonal of the screen. So if I turn a 2-inch phone into a 15-inch wearable display on my eye, and I've seen these devices and they do work, then I've just increased my data rate requirements by 50-fold in one hit.
Yep.
So Fred, devices are doing these amazing things. What's the status on the battery? Are we going to be running out battery much faster than we are doing today, or there are going to be breakthroughs in technology for battery as well?
Yeah, actually, we do have sort of an initiative around that because people really would like their phone to be more or less like a watch. It's something you want to put on, not think too much about. We actually just introduced a phone that we were thinking about making a very green phone. It actually uses a 100% recyclable, sort of like Patagonia's recycled plastics and things. But the thing was that as a consequence, actually, we ended up getting a 9-hour talk time and an 18-hour standby on a very low-cost phone. So it was just by engineering the whole platform in terms of the processors, the memory, and very efficient use of the radio. And particularly in video, you want to basically not continuously broadcast. You want to hold things and do a burst mode. So all those technologies come to play. The batteries themselves, we do have vibration ones. We have augmentation with solar. And but initially, when you get to the initial radios, typically come out, they take a little more power. And then, but the end state for even the next generation will be sort of what we have today. You certainly can get through at the minimum 24, 48 hours.
So it looks like it's more about optimization. But are there things like fuel cells that might come into the picture anytime soon?
Well, certainly most of the deployments, as we said today, really are around the netbooks and the laptops and some of these technologies. And the fuel cell actually is very appropriate for that. And as a matter of fact, the available fuels to run those things can be lots of different things, but actually one of the fluids of choice is windshield wiper fluid because it's so readily available around the world. So I think on that platform, you can do that really today. And the trajectory eventually will be for a mobile. As Hugh was pointing out, yeah, we have things about this big that are projection displays. There's quite a few companies that have them. 3M has a little small unit. And you can take those and project them on, well, I've tried projecting on my shirt, subways, and you can have a little social experience in addition to glasses. So those are all happening at the same time. Right now, you sort of get into sort of a cigarette pack size device.
So that might have significant impact on the data usage as well, because
yeah, as was pointed out, one of the why video is so compelling is because we have eyes and we like to look at things. The world is 3D, but also in terms of testing a system, video is the most demanding because it does go up as a square, resolution goes up square, and as you have many frames per second, we introduced a 30 frame per second phone in Europe, and we shipped the Bourne Ultimatum on it so people could watch a movie, and it's pretty darn good. But as you change the frame rate and the resolution, yeah, you're going up as almost a cube in terms of bandwidth.
Mm-hmm. Maybe let's talk about the ecosystem, because the ecosystem, as we know, is the most important thing in terms of launching a new technology or a new set of application services. Is the ecosystem changing with respect to who controls the ecosystem, where the revenues flow and how they flow from the consumers as you introduce new services into the marketplace? Is it going to be more internet players who are going to become more powerful versus, say, service providers or OEMs, or is it just too early to tell?
Certainly in our area, I mean, you see the two worlds colliding, of course. There's even the cable industry, which is very controlled, for high-resolution content. You see things like Sling, where that makes its way through the internet into mobile devices. And then it's sort of the over-the-top phenomena. And classically, a lot of people have expected content on the internet free, and in cable, you expect to pay. So we're sort of trying to look at how that will all shake out. And one of the drivers has been advertisement. So that's unfortunately one of the areas that we've focused on. And it seems to be working out because then it trades off because you can actually have a lot of information about the person that's actually watching the content when they're watching it. And you can sort of use that personalization to sort of tailor that so it's more like information and less like spam. So there's those two common models. One is sort of the fixed rate, getting more for application, not on a data plan basis, but more on a fixed monthly fee, augmented by advertising revenue.
Okay. Hugh, I'm sure you have thoughts on how service providers can maintain their viability.
Well, the best way to do that is not to offer flat rate plans, let me point out. I think in terms of the opening of the ecosystem, the notion that you're going to only offer walled garden services is long dead. What operators like ourselves are doing is we have what we call two tabs on our web portal. One is our internal walled garden where only our customers get access to it, and that traffic is unmetered. And then there's the wider web, which is metered traffic. And that works pretty well for us. We have a capped plan, but most users, we've capped it at a level that most users benefit from. It just it cuts off that 2.5% to generate 50% of the traffic. So those are the loud voices you hear complaining about it. But for the average user, it works extremely well. And then it takes a lot of heat out of the debate as to who's controlling it, because we're getting a fair return for our investment in radio network infrastructure, backhaul, and all the other things, the back office stuff that we put in to run the network.
I'll quickly get Rama's thought and then come back to Chris and David.
The new business model I was alluding to kind of goes straight at this point you just heard from Hugh, which is, if you look at today's business model, you cannot afford to sustain a flat rate charges, because the demand for data is insatiable. It'll just skyrocket. It has been skyrocketing, and how do you pay for it? But that's the difference between building a dumb pipe, which just provides bits, versus a smart pipe, which is what I call the open internet ecosystem, where it's possible to derive revenues from working with the application and the content providers. And that model is, Google did not exist until internet became reality. And Google's business model did not exist without internet. It spawned a whole new way of how advertisers and how content providers can reach the masses and how that revenue is shared. I think that's just tip of the iceberg when you take it to the mobile internet. There are whole new ways of creating those revenues and sharing them, which are possible in the 4G, which are not possible today in the walled internet approach of the 3G world. Okay.
So we all have lived through the 2G to 3G migration and the fiascos of 3G early on. What lessons have we learned some things that we can apply towards the next migration?
I think definitely. I think if you look at what consumers have wanted, whether it's a business consumer or just a regular personal business, they want a few things. They want coverage, they want speed, and speed can include latency because that's the feel. They want applications, and they want to be able to use their networks anywhere they want, anytime they want. And I think our industry, when we came out with 3G, we didn't fully have all those components in place. And I think the recognition now for at least the GSM operators and the HSPA operators is that you need to be able to provide those 4 aspects to your customers. Whether that means that if you're in New York City or Chicago or Seattle or here in San Diego and you're using LTE, but if you get out of range, you're going to fall back to an HSPA plus network, which is going to be very compatible. So I think that is seen. We see people that are promising to work on the silicone earlier on. We've seen that for LTE. So it's going to take its time, but I think there's an understanding of what happened with 3G, not to make those same mistakes.
David, you have the last word.
Yeah, well, I think the issue of smart pipes is exactly part of that scalability too, is the ability to both scale up capacity and to be able to account for it so that you can have people that can take advantage of those extended services is part of what we as an industry need to provide in order to help drive forth that infrastructure. So I think companies like ours, we're working on our capabilities to be able to start out with 100 megabits and take it all the way up to gigabit or 10 gigabit, and then allow the users to pay for that capacity of those specialized services is part of what we have to do in order to help support that demand and not get stuck in flat rate type programs.
Okay, well, we have about 20 seconds if there are any question.
10-second answer.
I guess we are out of time. Well, please join me in thanking the panelists, and please feel free to interact with them afterwards.